Hello everyone, this is Ajmal from Afghanistan. My today's presentation is regarding sulfate acid in soft water attack on concrete. We will discuss how the attack occurred and what is the mechanism of the attack and how it is deleterious for the concrete. First, sulfate attack. Sulfate attack on concrete can be occur where soil or groundwater surrounded the concrete that have high sulfate contents. It would be internal sulfate attack or it would be external sulfate attack. When sulfate attacks from inside the concrete occurred, it means that if there is a source of sulfate inside the concrete and attack the concrete, it called internal sulfate attack. If there is attack occurred from outside to the concrete, it means if there are sources outside of the concrete and attack the concrete within the presence of the water, these sulfates enter the concrete and attack it. What are the sources of the sulfate that attack concrete? One of the sources of the attack is soil. If there is soil surrounding the concrete structure with high sulfate contents, with the presence of the water, it enters the concrete and attack it. If there is groundwater contains sulfate, it will also attack the concrete. If there is seawater adjacent the concrete structure with sulfate contents, it will also attack the concrete. If there is industrial environment, it will also contain sulfate that attacks concrete, especially industrial buildings. Sewer water is one of the sulfate sources. It will also contain sulfate and attack concrete. Flowing water is more aggressive than that of stationary because flowing water transfer new sulfate ions to the concrete and it will enter the concrete and attack the concrete. What are the mechanism of the sulfate attack? Sulfate ions attacks calcium hydroxide, which is one of the main compounds of the concrete, and the hydration products of tricalcium aluminate, which formed ettringite. Magnesium sulfate attack similar to sodium sulfate, however, form brucite. It primarily forms on the concrete surface and consume calcium hydroxide. Lower pH of the poor solution finally decomposes the calcium silicate hydrate. Over long period of time, ettringite convert to monosulfate because of availability of aluminate in the concrete. As we know that ettringite forms with reaction of gypsum and tricalcium aluminate at initial hydration process. When concrete hardened and over the long period of time, these attringites would convert to monosulfate because of availability of aluminate within the concrete. When the sulfate attack occurred by external sulfate and enters the concrete, it reacts the monosulfate within the concrete that formed from attringite, and it will start recrystallization of the attringite. As we know, attringite is expensive in nature, and it would be so deleterious for the hardened concrete, not for the soft concrete, as it forms an initial setting time. It will also expand and cracks the hardened concrete. As we discuss, gypsum reacts the tricalcium aluminate that form attringite. If there is excess gypsum remained in the hardened concrete, and the gypsum will dissolve sulfate ions, these sulfate ions continue to react with the remaining tricalcium aluminate to form attringite, which is also deleterious to the concrete. The internal stresses caused by attringite make the concrete cracked. As we know that attringite is expensive in nature, it will create stresses within the concrete and form cracks in the concrete. When sulfate attack the concrete, it will make expansion and stresses in the concrete. It will also create cracking in the concrete. It will also create scaling and spilling into the concrete. It will also degrade the concrete. This picture shows a test plot in California. There are many beams laid in sulfate-rich soil with the presence of water. After 7 years, it deteriorated. Most of them degraded and damaged severely because of sulfate attack. As we discussed that sulfate enter the concrete and attacks the concrete. There might be monosulfate formed after long period from attringite, and it would be attacked. It would be recrystallized by the reaction of sulfate with monosulfate, and these beams show that most of them deteriorated and most of them degraded and damaged. How to protect concrete from sulfate attack? One of the methods to protect concrete from sulfate attack is using of pozzolanic cement. Use of pozzolanic material means lowering calcium hydroxide that leads to decreased gypsum. As we know, calcium hydroxide create or form gypsum, and gypsum provide attringite, and attringite finally over the time convert to monosulfate. So lowering the calcium hydroxide will reduce the chance of sulfate attack. Lowering calcium hydroxide leads to reduce the system alkalinity. It means that ringite will no longer be more expensive as it is normal Portland cement. As we know that cement is alkaline in nature. When its alkalinity decrease or reduce, that ringite tend to no longer be more expensive. Use of low tricalcium aluminate cement would be one of the way to protect concrete from sulfate attack. Generally, a ringite forms in initial stage while concrete placed. So stable ringite will lead to decrease chance of monosulfate, which reacts later due to external sulfate attack. One of the best way to protect concrete against sulfate attack is providing better impermeability of the concrete. The better impermeable concrete would be so important and would be able to protect itself from sulfate attack. Just sulfate resistant cement cannot be adequate to resist sulfate attack. It is essential to limit ability of the sulfate to enter the concrete. So the better impermeability would be better to prevent sulfate enter the concrete. It would be accomplished by reducing the permeability of the concrete by two ways: proper curing and water cement ratio minimizing. If water cement ratio minimize, it means that we improve the impermeability of the concrete. If proper curing take place, it will also improve the permeability of the concrete. It will also improve strength of the concrete. When providing mixed design in the laboratory, the classes of sulfate, the exposure classes of sulfate is so important. It would be considered in mixed design accordingly. Waterproof barrier protection of concrete is also one of the way to protect concrete against sulfate attack. If we provide waterproof barrier, it will also prevent concrete from sulfate attack. Some of the cement types would be also better to improve the protection of concrete against sulfate attack. Type 2 cement is used for moderate sulfate attack, and type 5 cement is used for high sulfate attack. These are two pictures, different pictures with same type of cement. It is taken from Portland Cement Association, and with the different water cement ratio. Those beams with lower cement ratio tend to protect against sulfate attack better, tend to protect better against sulfate attack, and than that of the higher water cement ratio. Data from Portland Cement Association clearly shows that cement with water cement ratio of 0.39 not damaged in 16 years as the concrete with water cement ratio of 0.65 in 12 years. It shows that better impermeability is the best way in order to protect concrete from sulfate attack. Acid attack on concrete. Acid attack describes dissolution and leaching out of those constituents within the hardened concrete which are acid susceptible, such as calcium hydroxide. Acid tends to leach calcium hydroxide from hardened concrete. As we know that calcium hydroxide is one of the main compound of the concrete. By decreasing the calcium hydroxide, the strength of the concrete would be decreased. Concrete is severely susceptible to acid attack because of being alkaline in nature. As we know, cement is alkaline in nature, and lowering the pH of the cement would tend to be acidic. So it is alkaline in nature, it is more susceptible to acid attack. Here is some formulas that acid attack take place. Calcium silicate reacts water when concrete during the initial hydration process. Calcium it will create CHL and calcium hydroxide. This calcium hydroxide will later on react with the acid that attack the concrete. It will also provide or forms calcium salt and water. This calcium salt would be easy remove from concrete, and the concrete strength would be decreased. When acid attack the concrete, it will produce calcium salt, which is easily removable from the concrete paste, and it will also, the result would be providing capillary porosity, also loss of cohesiveness, loss of strength, and it will provide cracks. It will provide disintegration and also destruction into the concrete. In case of reducing the pH of acid below 6.5, concrete deterioration will be increased. Caused corrosion while reach to reinforcement. When acid attack to take place and reach to the reinforcement, it will corrode the reinforcement. Water containing bicarbonate with pH greater than 6.5 would be more aggressive, which severe when pH is equal to 5.5, and very severe while pH is equal to 4.5. As it contains free carbon dioxide, it will dissolve calcium hydroxide and attack concrete. Actually, pH is a measure of how acid is the water. The range is definitely from 0 to 14. Water with a pH lower than 7, it is considered acidic, and with a pH greater than 7, it considered alkaline. How to improve concrete resistance to acid attack? As we discussed before in sulfate attack, providing better impermeable concrete would be better, and it would prevent sulfate and also acid into the concrete. It will prevent water to enter the concrete. It would be beneficial for both acid and also acid attack and also sulfate attack. Properly cured concrete will also increase strength of the concrete. It would be beneficial for impermeability of the concrete. Acid resistance membrane around the exposed concrete is also one of the way to prevent concrete against acid attack. Using supplementary cementitious material is also one of the best way to protect concrete against the acid attack by using fly ash, slag cement, and silica foam. These are two pictures clearly show that at the result of acid attack, they have got damage, and they are damaged, severely damaged at the result of acid attack. These are also some of the pictures shows in two rows. The top row is after 28 days exposure with different quantities of fly ash from left to right. The left one is ordinary Portland cement, and the going right side, the fly ash content is increasing. The more the fly ash, the more the fly ash, the more would be concrete more protected against the acid attack. And the second row also shows the 90-day exposure. The first one, left side, is ordinary Portland cement, and going right side, the quantity of the amount of fly ash is increasing, and it will protect the concrete against acid attack very well by increasing the fly ash. Soft water attack on concrete. Soft water attack on concrete is considered while pure water is surrounded the concrete structure. When water reach to the concrete, pure water. When pure water reach to the concrete, it will also attack the concrete, because pure water tend to balance the ions contents in the environment. Water with low dissolved ion content leaching out CH within the concrete matrix, because soft water with low ion content tends to keep balance the ion. It will leach the calcium hydroxide from hardened concrete, because it tends to balance the ions amount, and it provides the best environment for acid attack if it happened. When soft water attack occurred, it will soften the concrete matrix, and it will provide disintegration into the concrete. And the damage would be depends on ion content within the soft water. If there is too much ion within the water, it will the attack would be more severe. How to prevent soft water attack on concrete? As we discussed before in acid attack and also in sulfate attack, the same thing happen into soft water. If we provide or improve concrete impermeability, it would protect concrete better against soft water attack and also acid attack, as well as the sulfate attack. Concrete additives are also one of the way to add in the concrete mixture to protect concrete against soft water attack. Getting or cutting off waterproof material is also one of the methods to protect concrete against soft water attack. Sufficient concrete cover is also one of the way to protect concrete and prolong the life of the concrete. Sacrificial concrete layer as around the concrete. It will also help protect the concrete against soft water attack, because it tends to protect the attack at the first line, because its location is at the first line of attack. It will improve the life of concrete. Provide impermeable soil around the concrete is one of the way to protect concrete against soft water attack, because if we prevent soft water from the concrete, it means we prevent the ions that leaching out the calcium hydroxide from the concrete. Thank you from your consideration. Thank you.